A 5 kilogram object with a velocity of 4 meters per second collides head-on with a 10 kilogram object moving towards it at 3 meters per second. The 10 kilogram object stopped dead after the collision. What is the final speed of the 5 kilogram object? Is the collision elastic or inelastic? You can also calculate the coefficient of restitution there between the two collisions. Alright, we got a 5 kilogram object moving with a velocity of 4 meters per second. M1 equal to 5 kilogram. V1I, initial velocity of the first object, 4 meters per second. And we are looking for the final velocity of that first object. What is the velocity of the first object after they collide? We are looking for V1F. And M2 equal to 10 kilogram. V2I is negative 3 meters per second. Why? Because they are moving against each other. If V1I is positive, V2I is negative. It's very important to consider the sign. And V2F is 0. Why? Because after they collide, the 10 kilogram object stopped dead. That's the second object. Its final velocity is 0. Alright. Since momentum is conserved for all collisions, you know that Pi must be equal to Pf. What is the total initial momentum? M1 V1I plus M2 V2I must be equal to M1 V1F plus M2 V2F. And we have all these values except V1F. We don't have V1F. So 5 kilogram times 4 meters per second, M1 V1I plus M2 V2I is 10 kilogram times negative 3 meters per second equal to M1 V1F. M1 is 5 kilogram, V1F we don't know. And since V2F is 0, this term will become 0. And you notice that here there is only one unknown. Look at that. The conservation of momentum really answers the first part for you. Solving there, you get 20 minus 30 equal to 5 V1F. And that gives you V1F equal to negative 2 meters per second. After collision, the first object went back with a velocity of 2 meters per second. Alright, what's the B part? Is the collision elastic or inelastic? How do you know? Well, we now know that V1F is negative 2 meters per second, and all these quantities we already know. The initial kinetic energy is 1/2 M1 V1I squared plus 1/2 M2 V2I squared. Using these known values, we get the initial kinetic energy is 85 joules. Let's now find the final kinetic energy. 1/2 M1 V1F squared plus 1/2 M2 V2F squared. We have all those values here. Replace these by their values. And that gives you the final kinetic energy is 10 joules. So what's the answer? Is the collision elastic or inelastic? Well, it is inelastic. Is that right? Yes, of course. The collision is inelastic. Let's also obtain the value of the coefficient of restitution here. Well, let me do that for you. What is the definition of coefficient of restitution? We have a E equal to V2F minus V1F divided by negative of V2I minus V1I, and that will be V2F is 0, minus V1F is minus negative 2, divided by negative of V2I is negative 3, minus V1I is 4, and that is equal to positive 2 on the numerator, negative 3 minus 4 is negative 7, and negative of negative 7 is 7. So you can see the coefficient of restitution for that collision is 2/7. In any collision, once you are able to obtain the velocities, you can obtain the coefficient of restitution. Alright, let's go and do another problem. A proton of mass m moving with a velocity of 300 meters per second collides elastically head-on with a stationary carbon nucleus of mass 12 m. You know that the carbon nucleus is 12 times the mass of a proton. A. Find the velocity of the center of mass of the system. What is the velocity of the proton after collision? Alright, we got here, this is the carbon nucleus, this is the proton, and the mass of the carbon nucleus is 12 times the mass of the proton. And you know the proton came and hit the carbon nucleus and was rebounded. M1, the mass of the proton is m kilogram. We don't know how much it is. It's enough to say m kilogram. Its initial velocity V1I is 300 meters per second. M2, the mass of the carbon is 12 m kilogram. Its initial velocity is 0. We are looking for the center of mass of the system and V1F. Okay, well, V center of mass is a simple equation. M1 V1I plus M2 V2I divided by M1 plus M2. And we know these values, 300 times 300m times V1I. Well, V1I is 300 and M1 is m. So M1 V1I is 300m. Since V2I is 0, M2 V2I is 0, divided by M1 plus M2 is m plus 12m. And that is 23.1 meter per second. The velocity of the center of mass is 23.1 meter per second. Since the collision is elastic, well, what is the equation for an elastic collision? The velocity of recession equal to negative of the velocity of approach. Alright, so we have V2F minus V1F equal to negative of 0 minus 300. V2I is 0, V1I is 300. So we got an equation for V2F minus V1F equal to 300. Well, can you find the value of V1F from there? No. We're going to say, therefore, V2F equal to 300 plus V1F. Alright? Now, using the conservation of momentum, we need one more equation to solve it because we don't know V2F. Using the conservation of momentum, we have Pi equal to Pf. Initial momentum equal to final momentum. And what's the equation there? M1 V1I plus M2 V2I equal to M1 V1F plus M2 V2F. Let's use all the given values. M1 is m, V1I is 300, so 300m, plus, since V2I is 0, that is 0, M1 V1F, that is m times V1F, plus M2 is 12m times V2F. Now that gives us 300 equal to, since m is present everywhere, we can divide by m. So m will go. We have 300 equal to V1F plus 12 times V2F. Now look at the way I have done here. This V2F has been replaced by 300 plus V1F. So 300 equal to, in this equation, this m has been cancelled. We got 300 equal to V1F plus 12 V2F. So that will be V1F plus 12 V2F has been replaced by 300 plus V1F. Now you have only V1 unknown. Distribute that and solve for V1F. It gives you 300 equal to 3600 plus 13 V1F. And solving for V1F gives you negative 253.8 meter per second. A very good problem. I want you to practice the method that I have used in solving this problem. I know I went through this a little quickly, but I don't think you need a lot more explanation than this. Let me know if you